Sir, we can start now, sir. Hello.
Yeah, yes,
Yes,
yeah.
sir. Yes, sir.
Okay. My screen is visible, right?
Yes, sir. Yes, sir. Clearly.
Okay. First, we'll open this board file.
Sir, your voice is little bit low.
Yeah, today we will see how to work on the AC analysis. Actually, for this we need to build a stack up already. I showed this in previous session. After that, yeah, yeah. Now simulate PI is there. In this analysis, analyze decoupling. Okay, this is the decoupling wizard. In this, three are there. Actually, in our company, always we are doing this lump analysis. Here, no, we need to select the particular net. Our net is power net is plus 3v3. With respect to ground, we need to select. After that, yeah, how many capacitors are connected for this particular power net? No? Although all are appears here. For these capacitors, we need to assign uh, S parameters actually. Yeah, see here. For this, we need to assign S parameters. Those S parameters we need to download from a manufacturer website actually. Already I downloaded S parameters. Okay. Yeah. To assign S parameters, for this also we need to select the path, same as like where we are assigning for IBS models. No? There only we need to assign this path actually. Yeah, here. After assigning this path, next. Yeah, here we can select these capacitors and assign models. Assign models. Here we need to select touchstone. That particular part number KGM21. KGM21, this one. We need to select this. After that, we need to click on OK. Now that model is assigned here. And for this, yeah, second. So yeah, this GRM32 touchstone. First one. For this also KGM20. Yeah, for this capacitor already I searched, but I didn't got the S parameters. This time, no, we can assign this ESR value for this equivalent series resistance. Here we need to select that capacitance. And I think I saw this is like 5.3 ohms maybe. We need to add that ESR value. Then okay. After assigning models, next here we need to select this power net. Then here we need to calculate the target impedance. This peak current means in the total current we need to take like 50%. In this case, our total current is like 3.3 plus 3.3 plus 0.00003. In this, we need to take 50%. After that, here that supply voltage 3.3 and the ripple percentage is 3%. Yeah, this is our target value 330 milliohms. After that, yeah, here we need to set the frequency. Actually, we are in Sienna, we will simulate up to 100, 125 like that. After that, next, run analysis. That will be appear in touchstone viewer. Yeah, actually, this is our target. This is our capacitor behavior. Yeah, actually, this curve is below this target. Then we can say this is the passing like that. Actually, if you want to change this target color here in this view option, targets is there. This we need to select that. We can change color also. Yeah, this is the result for this 3v3 power net. If this curve is beyond of this here or somewhere here, no, then we will consider like that as a fail. For that, we need to suggest if suppose here it is failing means 1000 kilohertz to 10 megahertz. In this region, if it is failing, we need to suggest them which capacitors are operating in this frequency. We need to suggest like that capacitors in this actually. Yeah, you in this any doubts or so?
Yes, Suma. I can hear Suma.
Yeah, yeah. Actually, this is completed. If you have any doubts, yeah, actually completed service. So up to yeah. Finally, we need to send this like a report in Word document to customer actually.
Sir, actually the glitches will be there,
Huh.
right? The top something it is going to positive and again it comes to negative, like
Uh,
so
this one, sir.
beyond 0.01 and again it is comes to down. So any reason for this one, or how to interpret for this one, sir? Actually, for analog AC,
Okay,
ACs.
okay. For this, Ravi will answer for this.
Actually, here
Karthik, this one.
x-axis denotes a frequency and y-axis denotes what? Actually, it is farad or something else.
And the red one is PDN curve. Yeah. I can explain the this curve. Okay.
Ah, yes.
The up is there, no up curve. Up one. Yeah,
This
up one is the how you routed the shapes, how you put the shapes. The power is going to from VRM to load, VRM to FPJ. There is some wires, there is some cutters, there is some in between. What is that? Shape cutters, neck in between. VRM to load means sync to regulator to up to FPJ. There is some wires, there is some cutters, there is some neck width in the shapes. Because of that, they're coming like this. There is some induct. This is upwards is inductive nature, downwards is capacitor nature. Okay, now
Okay,
understand,
upwards is inductance, downwards is capacitance.
right?
Hello.
Yeah, capacitance. Yeah,
Okay, okay, sir. Okay,
yeah. Karthik, I can hear.
okay,
Yeah,
sir.
always the inductance going to upwards. Wherever the neck width is there in lever, the it's indicate that it's inductive nature.
Okay, sir. When
Always we have
how
to.
to we can classify it as failing or passing in from this signal? Whatever we have shown,
Uh,
it is whether it is
yeah.
passing or
If
failing. How
yeah,
to classify it?
yeah, yeah. Actually, the PDM crosses the green line, right?
Yes, sir. Yes, sir.
It yeah, the PDM is failing.
Okay, okay. When it is crossing
Yeah,
green line, right?
yeah. If it
Okay,
crosses the green line, the
okay,
PDN curve is the PDN analysis is failed.
okay, sir. Okay,
So we have to make the pass means we have to add the capacitor at particular region, which capacitor operating between the range, some 10 kilos to 100 megas, 100, 10 to 20 megas, whichever capacitor operated in between the range, we have to add in layout at
okay,
particular region.
okay, sir. Okay,
Then
okay,
we have to minimize the inductance and capacitance both.
okay, sir. Okay, okay. Fine, fine, sir. Okay. Actually, what are the input parameter we are going to use for this AC analysis, sir?
Actually, we need list of power nets, power and ground,
Okay,
and which is how much the current carrying this power net, what is the tolerance, what is
okay,
the yeah, what is the transient current,
okay, sir. Okay,
and target impedance values. These
okay.
are inputs required to PDN analysis.
Okay, these inputs are available from where, sir? From data sheet or customer given?
Customer should have to give these current values,
Okay, sir.
and S parameter download from your manufacturer website, or customer have to give this
Okay, sir. Okay. Okay. Sir, actually, whatever you have shown this result, it is based on our previous discussion, same file, right? DC file. Actually, we have
Yes
shown
sir,
this
yes sir.
same file. Okay,
Yeah,
okay, then fine, sir.
yeah, same file only. Yeah.
Actually, how to add this result in our document, sir?
Yeah,
Actually,
just you can actually you can take this print.
okay. Actually, for making a
Yeah,
report, we have a
yeah.
lab. We have PCB lab
Okay.
laboratory
Yeah,
process.
yeah,
So we need to include this in our laboratory experiment. This is one of the experiment
yeah,
we.
yeah.
So that's why, sir.
Okay. Yeah, you can take this print and directly you can mention that power net name and how much this how much is your
show me on plot Suma, then we can understand. Show me on
okay. Yeah.
video.
Yeah, in our report, no, we are list out this all power nets and that stack. Yeah, this note also and this target impedance calculation formula and stack up. Yeah, this is the table for that. How much our target impedance and power net and peak transient current. After this, yeah, this is our power net and here the target impedance and what is the tolerance, and this is the range for how much frequency we ran the simulation, and this is the curve. We can take this in a PDF print actually, then we can add these results. Yeah, like this we can add in report.
Actually, what are the pins we are going to concentrate for AC, sir? AC analysis,
The power pins actually, power and ground pins.
power and ground pins.
Yeah. The purpose of doing this PD analysis, we have to minimize the resistance from regulator to FPJ.
Okay.
As soon as much as possible, we have to reduce the resistance in between path. Then, as per maximum power transfer theorem is there, no?
Yes, sir.
Maximum power transformer. Yeah. So we have to send the maximum power to load
Okay.
to in between reduce the resistance in between the from regulator to EPJ.
Okay, sir. Okay. So AC analysis, especially for power and ground analysis, right?
Correct, correct.
Power pins and
And
ground
ground
pins,
pin. Yeah, correct. We have to reduce the resistance power.
reducing the
Resistance in
resistance.
between power.
Okay.
Yeah. And
Sir,
also this
this
is the
one
ground
input
pins
and
for
output pins, IO pins like.
IO pins is come under this signal integrity.
Okay, sir.
Correct, no?
IO pins is signal integrity. Okay.
Yeah, it's come under the signal integrity. Both input and output pins. But in power, no,
Yes, sir.
there is no
Yes.
input and power. Only this is only supplying the power, right?
Yes, sir. Yes, sir.
From
Okay.
regulator to load AC. Yeah.
Okay.
Okay, sir. Then I have next at 11 meeting is there.
Okay, sir. Okay. Okay. Okay, sir. Okay.
Yeah. Okay.
Okay,
Then,
sir. Thank you so much, sir. Somshekhar and
okay, sir.
Ravi Kumar.
Yeah. Okay. Yeah. Thank you, sir.
Thank you,
Thank
sir.
you.
Thank you so much, sir. Can you send
Okay.
me the report for our this one for document purpose? Actually, we are
Yeah.
making a PCB lab manual, so this DC
Mm-hmm.
analysis and AC analysis report also required to add
Okay.
these things, sir. So that's why.
Okay. Okay. So once I will discuss with our manager and I will
Yeah,
send it
definitely,
to
sir.
you.
Definitely, sir.
Yeah. Okay, sir. Okay then. Yeah. Bye.
Bye, sir. Bye, sir. Thank you, sir. Thank you.
Bye. Okay. Okay. Bye.